I got stuff for you.
Holy moly. I need to get some snakes and release them around my house.
But they love eating people. They love eating kids.
These guys are the scientists of the supernatural, lecturers leaving lessons for inquiring laymen. They are applying the scientific method to a world that baffles science. They are the cryptids of the corn.
Every day that you open your mouth,
I know, right?
I'm more convinced that you're abducted by aliens.
No.
And it just stood up. I mean, it just like kept going and going. And she goes, what the?
These are idiots.
I was laughing reading this because I already knew how you would feel.
Idiot. What part of the story fits your balloon?
Well,
This isn't a UFO. But who else has big black wings and red eyes?
Batman.
Well, Mothman.
Oh yeah, Mothman.
Well, everyone, I think we know exactly what it is. So say it all with me. It was the sandhill crane.
Would you try it?
No.
You wouldn't eat it?
No.
Why?
Because they're probably toxic. There'd be a lot of poop in my pants. I've seen a 6-foot alligator go swinging through the air and slam into a tree. Welcome back to Cryptids of the Corn podcast.
We're back.
I am the great and powerful Mystery.
And I'm J Clone. 27.
Disgusting number.
Very special number. It is. It's one of the best numbers in the world. 27.
And today's absolutely titillating topic
Oh.
is of the high-flying variety.
But don't tease me with your titillating topics.
Now, I hate doing this soon in the season, but I just couldn't wait. But this may be my favorite episode of season 5.
And at this point, I bet you it is.
Well, yeah, at this point, definitely. But I'm scheduled out to like episode 10, 11-ish.
Okay.
And this is one that I just have been so excited for. But yeah, do you know what it is? Do you remember?
I do remember.
Okay. Sometimes you don't. Before we get fully into it, I just have a couple real quick things
Okay.
to get into. Frogman Fest is coming up. It should be in a couple weeks after this episode airs. I think roughly either that or the next week after.
What's the actual date?
The 3rd, right?
March 3rd?
Yeah.
Okay.
The first weekend of March.
Oh, I figured
down
you had it
Loveland,
pulled
Ohio.
up on your phone.
No,
right
I
there.
just, if you guys are coming and you want to hang out, we're going to do a hangout on Friday night. I think we're going to go to the Monkey Bar. It's kind of the plan, but if you're going to go, message us or email us, do something, Instagram, Facebook, email, to let us know you're coming, and we'll let you kind of know where the group's heading. Last year, we had a pretty nice group and a lot of fun, hanging out with everybody.
Really fun, yeah.
That's where the double hat thing started with Jay.
Oh, that's right.
The famous double hat where he's wearing 2 hats, he didn't realize it. And then everybody else started putting on 2 hats. And he's like, why is everybody wearing 2 hats?
Is that what happened?
Yes.
I don't remember.
You may have had a little bit of that red pop alcohol a little too much.
It was a whole year ago.
Mm-hmm.
And I don't live in the past. I live in the now.
And then I think on Saturday after the conference, after the movie, because they're premiering the new Frogman horror movie, I think we'll go to a local Loveland bar.
Sounds lovely.
Which Loveland's a cool area. It's like I said, it's my wife Emily. It's her hometown. The in-laws and the baby will probably be there, but Emily will not be. She's working that weekend. She wanted to. She's gearing up. We're having twins. I don't know if we mentioned that, but so she's trying to get on all the hours she can before it's time to rest.
Right.
But yeah, so I just wanted to mention that about Frogman. If you're coming, let us know. We'd love to hang out with you guys. I know we already had a bunch of you have already reached out to us, and I'm so excited. It's gonna be a lot of fun. Okay. The mispronunciations from the season finale. First off, the season finale, you guys, the most emails we've ever gotten about anything. Almost all good.
Okay, good.
I'm going to take that back. They all were good. We got some Mormon emails that were some really good information and stuff like that.
Yeah.
And we made, evident in that episode, we know nothing about
Still don't.
Mormonism. I know a little bit more now.
Right,
I've
yeah.
had some amazing people reach out. The pronunciations were a big thing.
Which, if you're a listener to our
Everybody
show,
was super nice about it.
yeah.
But I didn't know how many listeners we had that lived there.
Ah,
So we had like people from what I was calling Dutchess.
yeah.
We had people that in that town listening and be like, where the heck's Dutchess?
What's that? How's he really say it?
I don't have it in front of me now. So it's
Okay.
But Like vernal was one. I did pronounce that one because it smelled like vernal pool. But yeah, there's just a bunch of stuff out in the Uinta Basin I was mispronouncing. But all the emails and all the messages were very, very kind about it.
Maybe next time we do a big episode, we should reach out. Hey, we have anyone that lives in this area? Please reach out.
Please reach out.
Because we will use you as a resource.
So I have 2 salamander things. We are planning our second Patreon outing. So that's like a big weekend camping trip with all of our Patreon members. So if you want in on that, get in on the Patreon or the paid member space, either one. The links for both of those are below. But it's going to be a salamander hike weekend through the Great Smoky Mountain National Park. And Jay Clone 27, what is the Great Smoky Mountain National Park known for specifically?
Now, if any of you listeners didn't know this, prepare to have your mind blown. The Tennessee, the Great Smoky Mountain National Park, is famous and known for being the most biodiverse place on the planet for amphibians,
Specifically?
salamanders, and newts.
There's 2 species of salamanders that are only found in the park.
Ain't that insane?
Yeah, and the
So-
first time me and Emily went, we had like a crowd, not on purpose. It was just me and Emily doing our hike.
Gathering.
And I was telling everybody, like, the Smoky Mountain Dusky Salamander's the rare one. Green salamanders are pretty rare. And, like, we flipped 2 rocks and found all 3 of the rare species, like, instantly.
Right there. That never
Red
happens.
salamanders, spring salamanders. It's going to be so much fun. So if you want in on that or you want more information, join Patreon or the paid member space. They're the same basic thing. It's just if you don't like Patreon, we have an alternative. And I know there's a couple of people on there and working it fine. They were really enjoying it. So it does work. I finally got one person to tell me it worked.
Woohoo! And it wasn't me.
Now, speaking of salamanders, we're going to go hunt the Trinity's Alps giant salamander. We're going to do that in most likely 2025 in the early summer, late spring, somewhere in there. But there's a Kickstarter for that. So if the Kickstarter gets funded, we'll do it. If not, it's fine. It's just how life works. So the Kickstarter will start mid-March. So kind of watch for that and it'll run for 2 months. But yeah, we have biologists, we have treasure hunters, we have underwater photographers. Jay bought a
Underwater rover.
500-foot depth limit.
Yeah, which was, that. I'm in the hole for a little bit, but you know what? When it came available, I had to do it for the documentary.
So we have a really cool team put together, and it's really
the best team probably ever assembled.
if it's still out there, we're gonna find it.
Yeah,
I mean, we have. Well, I worked with salamanders, but we actually have I can't name them yet, but a state salamander biologist or herpetologist is coming with us also that works with hellbenders.
we got a loaded crew.
Yeah. So looking for hellbenders, which are really hard to find, which are giant salamanders.
Yeah.
So we have people that are professionals at looking for things that are hard to find, and they find them. But that's pretty much, I think, all of my stuff. There was one comment about Native Americans from the season finale, that they were killing each other well before we got here. And sure they were. People do that. All people have done that forever.
Yeah.
I don't think I ever made any comment that they weren't. But for the Uinta Basin, specifically, we're talking about a lot of the white settler and Native American conflicts.
Right.
So just saying, that was just a notion that got brought up.
Okay. I was gonna say what was the context for, but all right.
Yeah, now to us, it's like 3 months ago. It
Yeah.
feels like we're
Feels
recording
like
that.
it, yeah. Felt
All
like
right.
3 months recording it.
We're going to talk today about,
You want me to say it?
yeah,
Aeroplankton.
I'm trying to be nicer to you in season 5.
Well, I just thought this one's literally right down your alley.
Oh, don't worry. This will be probably the most sciencey episode
That we've ever
of
done.
season 5.
Oh, just of season 5.
It's going to be up there, top 3 or 4 of most sciencey episodes.
All right.
Because there's not very much with what we would call the paranormal, supernatural, or cryptozoological until kind of the end.
Right.
So it's really all just stuff that's documented. So aeroplankton, or aerial plankton life, are tiny life forms in detritus that float and drift in the air, carried by most wind currents. Most of the living things that make up aeroplankton are very, very small to microscopic in size. Many of them can be difficult to identify due to their tiny sizes. Scientists collect them to study in traps and sweep nets from aircraft, kites, balloons, and the device we talked about in our early organic UFO episodes, like the Hestrodendy-like devices. So it's funny, the nets they're using, the sweep nets, are almost the exact same one we use for plankton
Okay.
and larval fish, because there's some species of larval fish that are microscopic.
Really small. Yeah.
So it's just kind of neat. Once again, when we talk about this, it's going to be literally, it's called aeroplankton because of the mimicking of the oceanic life. And we've talked a lot about whales in the upper atmosphere. And now we're going to talk about the building blocks.
The little guys.
Once you start hearing some of these numbers, you're not going to believe it.
How much they line up or overlap or what?
Yeah, it's just crazy. So, they use kites, balloons, but this is mostly limited to the... Stop yawning.
I'm trying to hide it from you.
This is mostly limited to the troposphere, the sphere we live in, and we'll talk about it a little bit into the stratosphere.
Oh, no way.
But yeah, aeroplankton is made up mostly of microorganisms, including viruses. And they've identified, you want to guess how many species?
How many viruses? Or wait, what'd you say?
How many species? Oh, sorry. Including a ton of viruses.
Okay.
Bacteria, you want to guess how many species of bacteria we've identified that live in...
Ooh.
So this is either they fully live in the upper atmosphere or they spend part of their life cycle up there.
6.
1,000. Now here's the fun one.
Okay.
How many species of fungus do you think we've identified in the upper atmosphere?
800.
40,000.
Oh, yeah, that's pretty different.
Huh. It's almost like they're all mushrooms.
It's like, that's 40,000 different?
Species, yes, in the upper atmosphere. And now, once again, that's not saying they all live in the upper atmosphere, their entire life cycle.
Right.
It just, some of it is spores, which we'll talk about. Some of it is actual growing mycelia networks that are kind of floating like spider webs or kites.
Okay. Oh, that's kind of creepy.
Isn't that weird?
A little bit.
And how maybe a couple 100 million years of evolution may have turned them into giant organic UFOs or something? I don't know. We'll talk about that.
It could be a possibility.
It's a possibility. Anything's possible. Hundreds of thousands of species of protists, algae, mosses, and liverworts, which are plants that live in a part of their life cycle as aeroplankton. Often others, things like spores, pollen, and wind-scattered seeds also end up in these big blooms.
Makes sense.
So there's just a lot of nutrients. That's what I'm getting at.
Yeah.
A lot of food and a lot of life built around these things. We'll even talk about some of the arthropods that end up there.
Like crabs?
Crabs, insects, that kind of,
Okay.
arachnids, those are all arthropods. And
That's right.
Think of the exoskeleton guys. So
That's
pretty much
right.
all arthropods. Not all, but... So what do you think so far?
It's teeming with life in the atmosphere. Whether you know it or not, or you can see it or not, there's a lot of stuff going on up there.
Yeah, and it's really, so far, very, very highly mimicking the open ocean environment or any water environment. So we're going to talk a little bit more. Small drifting aeroplankton are found everywhere in the atmosphere, reaching concentrations up to 10 to the 6th power microbial cells per cubic meter.
Okay, that sounds like a lot.
It's 10, like the number 10.
Right.
With 6 extra zeros.
Oh, no, I get it. I guess just picturing it in your head is hard
There's
to
that
do.
many microbial cells in square meter in the upper atmosphere.
Yeah, that seems dense.
It's not like super dense, and that's an average, right? Some areas, which we'll talk about, the actual clouds of these things.
Yeah.
Think back to our raining meat, our blood clouds, and all that stuff.
Yeah.
They may have already been proven, and nobody's really connected the dots.
Okay.
So, anyway, small drifting aeroplankton, they're highly concentrated. Process such as aerosolization and wind transporting determine how microorganisms are distributed through the atmosphere. Air mass calculations globally they are vastly different depending on where you're at.
Okay.
With these creatures floating in the atmosphere. They travel across and between continents very easily, creating biographical patterns by surviving and settling in remote areas. So they have found, there's a question of some of these fungus, some of these plant life and stuff like that, of how they're ending up so far across different continents. Mm-hmm. And they almost always end up in extremophile environments. So maybe there's a spring on the top, a warm water spring on the top of a frozen mountain.
Okay.
So there's 60 cubic feet of habitable land. And you have a type of fern that's only found in the Pacific rainforest.
And it's there.
And it's there too.
Okay.
So we don't have any fossil record for that. So how did that species get there? Well, there's a good chance it was aerial drift.
Right.
But yeah.
Blown up in the atmosphere and landed there. Well, what are the odds it lands in that one specific spot?
Well, it's more that these plants and fungi and small animals do the number strategy. pumping out billions of spores.
So the odds are one of them's going to land
Yeah,
there.
because they sprinkle kind of everywhere.
Right, yeah, that makes sense.
And they just don't take hold where other stuff is.
Yeah.
Or if they land on an ice sheet, obviously it sucks.
Yeah, I ain't going to do nothing.
Yeah. At least, maybe in 10 million years when it's not there. Or the continent cruises into the tropics.
It just all, it livens up.
But yeah, we're actually mapping these biographical patterns. And we are seeing these jet streams essentially, but the larger ones for life in the lower and upper atmosphere. Already isn't this amazing?
It's intense.
We're mapping planktonic life like we do in the ocean. And once again, where you see these giant plankton blooms or these schools of plankton where they're ending up, you normally find whales and a lot of fish and stuff like that. They're the base, they're the building blocks for a food chain.
Well, if something's of that out there in that abundance, something's going to eat it.
Something has to. I mean,
Right. Or else it'll just grow. They just keep multiplying and multiplying and multiplying, right?
yeah.
Wouldn't that just be the case?
Yeah. And I guess a lot of this stuff isn't fully living in the upper atmosphere its entire life cycle.
Right.
But they are spending a good portion or some part of their life cycle up there. A good example for here, terrestrial and aquatic, is horseflies. Horseflies are actually an aquatic insect. And most people, when I just said that, are probably thinking, how is a flying, biting insect an aquatic insect? Their life cycle starts in the water. They are aquatic grubs. They spend until they hatch and come out.
Didn't know that.
Yeah. So a lot of those actually biting flies start their life in aquatic states.
I can't stand those things.
So that's kind of the inverse of what's happening here.
Yeah.
Some of these life cycles are starting in the upper atmosphere and then maybe ending up in water or terrestrial.
Work their way
terrains.
down.
Yeah.
Trickle down.
Trickle downs. So as well as they are colonizing pristine environments, these globe-trotting behaviors of these organisms have human health consequences as well.
Uh-oh.
Some of the random weird diseases that have popped up and disappeared, maybe as far as human history,
Right, yeah.
may be a result of these giant biological patterns in the upper atmosphere. And that every once in a while, a thunderstorm knocks enough of these down to kill a town.
Makes people sick.
Yeah. And then it disappears again.
Is that... I never thought about something like that.
So, because these plankton have, depending on which species, whether fungus, virus, bacteria, whatever, have evolved separately for such a long time, but they're still related to us, they can make us very sick.
Right.
But they don't spread very good on the ground. They're carried by air. So if they get dumped on a town, the town dies.
Right. And like a fungus, I mean,
Yeah.
you can't, like mold, and it's like be breathing in mold.
Or virus, bacteria, it doesn't matter
Right,
which
yeah,
one. Dumps in this town dies, but nobody can figure out why.
Right.
Everybody died due to sickness, but when a new person comes in, they don't get it because they weren't there when it was dumped down there.
Right, exactly.
And a lot of these around thunderstorms are weird weather phenomena. So that would make sense. They're kind of, imagine this thunderstorm is scraping the bottom layer off and throwing it down towards the
on you.
surface.
Yeah. It's a good thing onions grow underground, because if they got whipped up in the upper atmosphere, you'd be toast.
Now, here's one you probably have no idea exists.
No.
I'm getting more and more excited. We're only 18 minutes in.
Right.
Airborne microorganisms in the upper and lower atmosphere are also involved in a lot of cloud formation and precipitation.
Well, that makes sense.
These guys can form clouds from their existence.
Okay. Is that why they're spraying up there, is to kill these? So they have control of their cloud formation?
They play important roles in the formation of folly spheres, a vast terrestrial habitat involving the nutrient cycle. Upper atmospheric plankton are the building blocks for not just the upper atmospheric environment,
Right.
the whole planet's nutrient cycle.
Wow.
Just like the deep ocean upwells,
Yeah.
it's the exact same thing. We're in these two big spinning vortexes of nutrients.
It's like the
And
rain cycle.
It is, and it's also partially forming the precipitation cycle.
See these. Okay.
When we see these organisms grouping up, we see clouds forming, and we don't know. So snow, rain, and stuff needs what's called a nuclei.
Yes, like a little
something
piece
to grab
of
onto.
debris yeah.
A lot of times, it's a living animal.
That would be nuts.
It is. It almost always is, or dust, or anything like that.
See, I was always taught in school was a piece of dirt.
It can be.
Yeah.
Detritus is what that's called.
They say every time. They never said
Little animals?
phytoplankton. Is that a thing? Phytoplankton?
No.
Okay.
Oh, phytoplankton is, yeah.
Okay. Not in the atmosphere, though.
I mean,
Could be.
there are. We'll get there.
Okay.
We'll get there.
Okay.
Calm down.
I just want to sound.
Calm down.
You're throwing out all this science information. I'm trying to fit in, okay?
So everything I just told you is scientific data. And we can say whatever we want about science and stuff like that, but it's been tested, proven multiple times. They have these. We're going to talk about equipment here in a second, of how they actually test and catch these animals and stuff like that, because it's very unique. What's weird is so when we originally did this, I only found the NASA study.
Right.
And the NASA study was it didn't look like it was standing on any shoulders of giants beforehand. Looked like they were starting their own thing with no previous
Like they
data.
figured all this out.
But they didn't get this far. This has been a group of biology for over 100 years.
Okay.
Since we started getting weather balloons up there and hot air balloons.
Then why aren't we taught about any of this ever?
It's if you go to school for like microbiology or, probably meteorology, you probably hear some about it.
Gotcha.
But this is a high-end part of a high-end part of a high-end part of a certain science.
I guess so.
It's to get to this rabbit hole, you either got to be looking up organic UFOs 24/7 or be an aerial microbiologist.
Yeah. Like very specific to this.
Yeah.
Okay.
But it's just crazy to me. What do you think so far?
I didn't know like all this was going on up there, but that's a lot of nutrients. I like how you compared it to the ocean swells of nutrients that kind of rotate up and down in the ocean. So if there's that much stuff up above us, obviously it's creating the same scenario, just falling down and creating nutrients. Also the part of it being a living creature, like in the middle of each raindrop or a snowflake.
It doesn't have to be, but it can be.
No, it can be. I didn't even think that was a potential for a thing before. So that's kind of mind-opening or eye-opening, however you want to look at it. Mind's eye-opening. That's how I'll refer to that. Mind's eye-opening. Put that on a t-shirt.
Mind's eye-opening.
Yep.
All right. Ready for overview and sampling?
Oh, yeah.
Okay.
Let's get the overview here.
And a lot of this, so I pulled some of this from Wikipedia, some of this from other websites. I didn't say that at the beginning. But there's been a lot done to this. And this is a very new version of the old science, if that makes sense.
Yeah.
We kind of always knew this stuff was there, but the way we're able to sample it now over the last 2 decades.
Changed dramatically.
Dramatically.
Yeah.
And our understanding is always changing. So like any science, it's always progressing, or it should be always progressing, and new data can replace this data very quickly.
Right.
I just like pointing that out because some people, science and non-scientists, think once we say something, it's set in stone.
Right.
The animal Spinosaurus is a perfect example of they change it about every 6 months.
Oh, makes sense.
And every time they do a study, it's a different animal.
Well, it depends who is the science that day.
There you go. So the atmosphere is the least understood biome on Earth, despite its critical role as a microbial transport medium. Recent studies have shown microorganisms are uniquely spaced in the atmosphere and reach concentrations, like I said, up to 10 to the 6th power microbial cells per cubic meter. And they are most likely metabolically active.
Okay, so they're eating or feeding.
Yes.
Okay.
So they're not just, 30 years ago, most biologists would have said everything up there is in stasis.
Okay.
Like all this stuff is probably in stasis. It's still up there, spores and stuff are just kind of waiting to land again.
Exactly, yeah.
Now we know at least some of them are metabolically active.
So they're eating out there.
They're eating. They're actively, burning calories and gaining calories.
They're not just floating around or got caught in an updraft and they're just hanging out.
So different processes such as aerosolization may be important in selecting which microorganisms exist in our atmosphere. Another process is microbial transport in the atmosphere is critical for understanding the role microorganisms play in meteorology, atmospheric chemistry, and public health.
Ooh.
So these little things that nobody really knows about are affecting dramatic environments here on the surface of the Earth.
That's why isn't that talked about, especially in the past?
Well, think about it. Nobody talks about plankton.
Right.
Who do you think? And that literally is what drives the oceans, which drive the world.
Right. Yeah.
So it's the same thing.
Yeah, we don't talk about that either. So
yeah. So I'm just saying, it's not like it's
makes sense. Yeah.
Conspiracy that nobody's talking about aeroplankton. It's just because 99% of people don't care.
No, it is a conspiracy.
We'll get there, but
okay,
they're going to saddle them up.
Ooh.
Change in species geographic distribution can have a strong ecological and sociological consequences. Man, those are a lot of big words.
Right back to back.
Back to back. In the case of microorganisms, air mass calculation, diversity, vast amount of individuals, and interceptions in remote environments. Basically, like we talked about these dumping events,
Yeah.
essentially, can cause whole new environments to crop up in the middle of existing ones. Well, I guess whole new ecosystems, whole new species groups,
Right.
can just cause. And we're talking at the basic level. Well, we'll talk about some of the bigger stuff they found in this study. Everything on here could fit on your thumbnail.
Okay. So everything in your is
Most stuff you can't see,
like we
with your
said at the
visible
beginning.
eye.
The small guys,
Yes.
the little guys.
Most of the stuff you can't see with your visible eye. The ones you can see are incredibly tiny, and there's a couple ones that are probably the size of like 4 or 5 of them could fit in your pinky nail. So nobody massive, but krill aren't massive,
No, and they feed
and they're
the biggest.
some of the biggest biomass on the planet. is
Yeah,
krill
they feed
swarms.
the biggest animals on Earth.
You got any questions so far? Any thoughts?
Oh, what are these guys eating? Phytoplankton.
Mostly, we're not talking about phytoplankton.
Or sorry, why do I keep saying that? Aeroplankton.
Aeroplankton. Most of the ones that are actively eating are eating spores, seeds, and detritus. Detritus is dead or inert, or organic or inorganic material.
Okay, so these guys are basically cleaning up there.
They are the bottom of the food chain. Anything below them is either a seed, a spore, or not alive.
Okay, makes sense.
So if in the water environments, these are the guys eating, like, think about like the bacteria eating the muck on the bottom of the water.
Right, yeah.
Plus a little bit of the guys eating those.
Right. So
So
they're
the bottom kind of 2 layers of living things is really what we're focusing on.
okay.
Anything else?
That's my only question I think I had. I mean, all this is kind of straightforward. It makes sense.
It's just so cool that
I wouldn't. I mean, you don't think about this stuff. You don't know. Like I said, no one talks about
see,
it.
we're barely into this, and we're already 30 minutes in.
dang.
I knew this was going to be a chunky one. The field of bioaerosolization research studies the taxonomy and the community composition of airborne microbial organisms, also referred to as the aero microbiome.
That sounds like a
And here's the thing, that's a little misleading. That word aero microbiome,
okay.
it's not a tiny biome.
No,
It's the massive biome of tiny organisms.
Yes,
I just wanted to point that out because if you just read it, it's kind of weird.
sounds like a small biome.
Yeah.
Right.
It's not. It's the biggest biome on the planet
Of just small creatures.
of a bunch of small.
Yeah.
A recent study, a series of technological and analytical advancements, including high volumetric air sampling equipments and ultra low biomass processing pipelines, low input DNA sequencing libraries, as well as high throughput sequencing technologies.
That's a lot of.
Now, we're going to break that down.
Okay.
Don't worry. To the best of my understanding, keep in mind when I was still an active biologist, I was a field biologist. I didn't deal with this type of equipment.
Right.
The most I did was eDNA, which is very small. But high volumetric air sampling. They basically have, it's like kind of like, this is not what it is, but the simplest way I can explain it. A tube where air goes through, and it basically catches everything on a screen.
Right.
And you can count all the species there, but it's super shooting air through it. So you can sample tons and tons of volume of air.
Like a giant traffic cone with a net on the back.
Essentially, yeah. But, you know, it's a high-tech device that does this. So, but it's sampling tons and tons of air in a little area. Mm-hmm. So you can find a lot of stuff. The ultra-low biomass processing pipeline means that we are getting a lot of, it's almost like eDNA in a way.
Okay.
That we're getting a lot of data from a little bit of biological input.
Okay.
So to catch a little bit, like the things we're getting with the high volume airflow, we can decide where we can better estimate the biomass as a whole. Low input DNA sequencing libraries means we can take very small fractions of DNA of this community and kind of build a library and see.
Okay.
Like we talked about DNA sequencing, like they need the library to compare it to.
Yep. They need the
We have
catalog
new
to
systems
reference.
that help these libraries do better.
Okay.
And then the high throughput sequencing technology is just sequencing the DNA better. As far as my understanding of these technologies, these are way above my pay grade.
How much of these did they find that are only found up there that they've
We'll talk
never
about
discovered? Okay. Okay.
A lot, not all. Most. It's more than half are not.
So how do they? Does that then get added to the catalog or the?
Why don't we wait until we get to species of the upper atmosphere?
Okay.
I have a little section called species of the upper atmosphere
We'll put a little pin in that one.
because you're asking questions that I think I'll answer.
Okay.
Okay. Applied in unison with these characterizations of airborne microbial organism dynamics found in near-surface atmosphere environments. So basically they're saying we're kind of predicting how we can sample up there with how we sample in the air down here.
Okay. Simple.
Yeah. Previous studies investigated bioaerosolization using an ACON sequencing focus and a bacterial fractioning of air microbiology, while fungal and plant pollen fractions frequently remain understudied.
Okay.
Fungus is one that gets ignored in this surveys a lot because they're too different and they're too hard.
There's just too much of them.
There's tons and tons and tons of them, species-wise.
Yeah.
There's a lot of them volume-wise, and they're very different to the plant people. They're not plants. So the plant people in these studies
Don't mess
don't
with
deal
them.
with them. Even though some plants that we're going to talk about have spores, like ferns. Ferns spore like a mushroom.
Okay.
But they're still alien to the plant people. The animal people, the microbiologists that are dealing with, animals, bacteria, that kind of stuff, they're alien to them too.
Right.
So you need, a fungal expert to really dive into these, and there's not a lot of those on the planet in general.
Maybe you should be an aerofungal.
I couldn't do it.
Why?
We'll talk about the spores of these guys. I couldn't do. The salamanders are hard enough.
Come on, you can identify any fish on the planet, probably.
I can see a fish.
Well, true.
And not on the planet.
Fair enough.
Definitely not on the planet.
Oh, come on. Don't sell yourself short.
So in recent years, next generation DNA sequencing technologies such as meta barcoding, as well as man, I cannot talk today. Magnogenomics studies have been providing new insights into microbial ecosystem functioning and the relationship with the microorganisms maintaining within our own environments. And there have been studies in the soils and the oceans and the human gut and everywhere else. Our last big frontier in this is the upper atmosphere. In the atmosphere, these microbial gene expression and metabolic functioning remain largely unexplored in the past due to low biomass and sampling difficulties. So far, these two systems have confirmed that high amounts of fungal, bacterial, and viral biodiversity exist in our upper atmosphere. It's just amazing that they're going with this stuff. Also, metabolic activity in aerosols and in clouds has been documented. So these clouds, there's stuff eating and reproducing in these clouds.
Within the clouds. Or is it the cloud themselves?
Is the cloud alive?
Or is there something alive in the cloud?
Or have we talked about, like, maybe sometimes these things are wearing a cloud?
Yeah, it's like covered.
Oh, how weird is that? I've never heard that before. Clouds throwing up blood or whatever,
Yeah. Never heard it.
Species found in the upper atmosphere. Before I move on to this part, which is I'm very excited for, what do you think? Any questions? Any thoughts?
No, it's all very, straightforward. So yeah, let's just keep going.
So we're going to talk about these things up in the upper atmosphere, the different types and then the species within them. Like I said, this is very, very not studied yet. They're gearing up to it. They're trying to understand. The early studies, there was low biomass. So they really couldn't figure it out. These new systems, they're getting there, but there's still a lot. So a lot of species can be mis-ID'd right now because they're similar to maybe a terrestrial cousin.
Okay.
Or we just don't know their species. Like we have tons and tons and tons of fungal spores and tons of bacteria and tons of small arthropods.
And don't know who they belong to?
We don't know their species.
Okay.
But we're finding so many of them, they can't categorize them fast enough. And it happens with, especially arthropods and bacteria on terrestrial and aquatic surfaces.
Yeah.
That happens a lot. That when you get into a new environment, let's say you find a new deep sea volcano. Each deep sea volcano's ecosystems are completely different than every other one, unless they're really close.
Okay.
Because it's cold in between.
Right.
So you have these organisms that are hyper-evolved for extreme hot, like the ironclad snail we talked about.
Yeah.
And even each species of ironclad snail is different on a different volcanic vent.
Makes sense.
Their species is one volcanic vent.
Because they ain't jumping around from
Right, because they
vent to
can't.
vent.
If they're surviving in 500-degree water, they can't survive in 30-degree water.
Right.
You got to pick one or the other kind of deal. Unless you're a tardigrade, which they come up.
I guarantee they're up there too.
Oh, they're just up there cruising, doing the cha-cha slide.
They're driving little ships.
Yeah. But I want to talk about what these guys look like. Like I said, I can't provide you a species name, but I can kind of tell you what these look like under, these microscopes and stuff.
Okay.
So first one we're going to talk about is pollen grains.
Pollen grains? Okay. That's pretty common.
Yeah. Effective pollen dispersal is, is needed for genetic diversity and fundamentalness for a lot of species on the planet, for plant life. The effective transfer of pollen guarantees successful reproduction of flowering plants. No matter how pollen is dispersed, the male-female recognition is possible by mutual contact of the stamen and pollen surfaces. So yeah, they're just saying that they're releasing these pollen to try to hopefully meet a female.
When we used to go to Canada and go fishing, we go up at a certain time in the summer. All the pine trees, everywhere's pine trees. You hit some time of the year, they were all pollinating.
Oh,
and literally through the sky or through the air, you couldn't. It was like fog, but it wasn't. It was just straight pollen. And then they would like on the water, it would all collect on top of the water. It looked like soap, like scum or
I've
something.
seen that with the pine trees. It's like yellow.
Yeah, yellow, green.
Yeah,
and it's just everywhere. It looks like scum, but it's
Where were
pollen.
we? I think we were in Georgia when we seen it.
It's nuts. It's
Somebody
nuts
hit one.
Oh yeah, and the whole tree
It's like snowing.
loses a cloud. Yeah, like it's crazy.
So allergy diseases are considered to be one of the most important public health problems affecting up to 35% of humans worldwide. There is a body of evidence suggesting that allergy reactions induced by pollen are on the increase, partially in high industrial countries. So basically, there's this thing that people are having these allergic reactions with the species of tree or plant or whatever,
Yeah.
and they're nowhere near them. And for years, it was a mystery of how this was happening. And now we know that these pollen clouds are essentially getting in the upper atmosphere, riding these jet streams around, and dumping on some unsuspecting city. Now, industrial countries, there's a couple different reasons. Industrialization can make you more susceptible to these things, like being around pollution and stuff like that. Another thing we'll talk about is air blockers or air brakes.
Okay.
Like mountains and skyscrapers
So
can cause this stuff to shoot up or slam right down.
Oh, gotcha. Okay, both.
So if you're in Chicago, for example, you can get dumped on by pollen from California.
Ooh.
Because it's kind of riding.
Until it hits that
And
building.
it's also hitting the Great Lakes and the buildings, and it just kind of dumps.
Okay.
So have you ever, I'm assuming you've seen what pollen kind of looks like, right?
Oh, yeah.
Most species of pollen are either, like, best way to describe it, little tiny balls with little spikes on them. You ever get one of those stress balls at Walmart? The little kids' toys. They kind of look like that. A lot of them are just round, purely smooth. There are some that are triangles, some that are Pac-Man-like. There's all kinds.
Didn't know that.
Mm-hmm. Now, the next group is much more interesting when it comes to us talking about living things, bigger living things in the upper atmosphere. Fungal spores, or their version of zygotes.
Okay.
So spores don't have to be just like a fungus's seed.
Okay.
They can actually kind of form into their own thing with their own mycelial networks, like a kite.
That's some strong seed.
Yeah. These guys are wacky looking. So, for example, I'm going to tell you, I'm going to try to pronounce their names for you. I'm going to describe their shape, and you tell me if it rings any bell.
Okay.
Corbelius stavius is a large, as relatively speaking, spore that is boomerang shaped.
Oh, that's it?
Yeah.
I was waiting for more. What's that remind me of?
Okay, so you got one that's a boomerang. I'll do another one.
Okay.
Arturia is a large teardrop-shaped spore.
Okay.
Dicelia alta is large and triangular, almost a perfect triangle. Photospore pholumiidae has one center body, one long stem, and then a kite of mycelia network around it.
Oh, okay.
Vorcuria ribosome is two large eggs looking like next to each other with one egg on the inside.
Each one has an egg on the inside?
Looking like, yes.
Okay. Okay.
Yeah.
Well, looking like, yep. Not just one between the two.
And then
of
most
them.
of these are like circles and dots and stuff like that. These are the more unique ones. A lot of these when you look at these charts of these guys, they kind of mimic the shapes of some of our big UFOs.
Oh, that's
just
what you were
small
getting
versions.
at.
Yeah.
Okay.
I was hoping you'd pick up on it. You normally ruin everything else, so.
Oh, the boomerang. I guess that threw me off because I'm literally thinking boomerang.
Boomerang?
Like, yeah, okay, boomerang shaped. Okay, is he like literally giving me the hint, hitting the nail on the head, or is there something else to this?
The joke is that a lot of them are actually UFO shaped. If I just took the names off this chart I'm using
And showed you the pictures.
and just showed you the pictures, a lot of our UFO friends would be like, yeah, that's a chart of UFOs.
Wow.
Even though some of them don't look like UFOs at all, but some UFOs, look completely.
You should try that. Just post a picture of these in the UFO group and say, these have all been.
You know who I made try this on? If I get to Linda Sigmund before she hears this, because she does all the UFO talks and stuff like that.
Are you going to try it on Linda Sigmund?
Yeah.
Okay.
And just see, because she's going to be at Frogman.
Try it with Daryl Sims, too.
He'd probably he'd probably be like, that's fungal spores.
Immediately.
So some cause asthma, such as Alteria, which one was that? I read that one for you. Oh, that's a large teardrop.
Okay.
A drawing of a very small dust seed. In this chart I'm using, you can see the dust seed. It's huge compared to all these guys.
Okay.
But some of these guys are actually actively growing mycelia in the upper atmosphere and kind of kiting around with them.
So they're like...
Once again, we know nothing about these spores or their version of a zygote. But there's no proof that they're controlled. Like they can kind of control and kite around where they want to.
They're just gliding wherever the wind takes them. Okay.
Which we'll talk about kiting events of arthropods here in a little bit. So let me continue. Fungi, a major element in the atmospheric bioaerosol, are capable of existing and surviving in the air for extended periods of time. Both the spores and the mycelia may be dangerous for people suffering from allergies, causing various health issues, including asthma. Apart from their negative impact on human health, atmospheric fungi may be dangerous for plants as a source of infection. Moreover, fungal organisms may be capable of creating additional toxins that are harmful to human and animals, such as endotoxin and mycotoxin. Considering the aspect of aeromycology research is considered capable of predicting the future of symptoms of plant disease in both crop and wild plants. Fungi capable of traveling extensive distances with the wind despite natural barriers such as tall mountains may be a practical relevation to the understanding of the role of fungi in plant disease. Notably, the presence of numerous fungal organisms in pathology to plants have been determined in mountain ranges.
Okay.
So once again, these dumping events.
Right.
Where you hit a mountain range, it's weird. There's just the fungal infections of plants go up, tenfold. I don't know that's the real number. I'm just saying, they go up dramatically.
Either way, yes.
Enough to point out that there's something up there.
There's something different, yeah.
So the aeromycology, there's no study in it. Very limited. I mean, like, what the 2 paragraphs I've just read,
Was the bulk of it?
There's probably 3 more paragraphs out there somewhere else.
See, if I go back to school, I could go to school with something like that. Like, I can...
You see, the problem is you need a teacher to get a degree in it.
True. I'll be like, well, yeah, I'll be the new teacher. I'm the science. That's what I'll say when I become the teacher.
I'm the science.
Yep.
So fungus have effectively taken over our upper atmosphere, like every other environment.
So did they take it over? They've always been that.
Well, they took it over just a long time ago.
Okay, yeah.
A wealth of collective evidence suggests that asthma is associated with fungus and is triggered by the elevation of the number of fungal spores in the environment. Interesting enough is reports of thunderstorm asthma.
Ooh.
You ever heard of this?
I have not.
So
Have you?
A little bit. Raina would always, my sister has asthma, would always get sick around thunderstorms. She has severe asthma.
Wow, okay.
And we never knew why. Now this is probably it. So, in now a classic study in the United Kingdom, an outbreak of acute asthma was linked to the increase in Direlium exeus aerospores and Sporobimureus aerospores associated with severe weather events.
Okay.
So thunderstorms are associated with spore plumes. When spores concentrate increase dramatically over a short period of time, for example, from 20,000 spores per cubic meter to over 180,000 spores per cubic meter in less than an hour.
That's a lot of spores.
And it's all species of spores mixed.
Right.
Fungal spores in pretty much every all air on the planet right now.
So we're breathing it right now,
Yes.
probably.
But the problem is when it gets overloaded.
Okay, gotcha.
Our bodies, especially if you're prone to it, can't deal with the new output. So these species we don't know extreme amounts about. And there's other species kind of cryptically hidden in here. That they're kind of being pushed along by thunderstorms or being knocked down by thunderstorms.
Okay.
So they can either be getting picked up from the ground from fungal bodies actually spreading spores right then and there,
Or
to
thrown
being
down.
knocked down.
Yeah.
Isn't that crazy?
It is kind of crazy.
Fungus are taking over the upper atmosphere.
Everything's mushrooms.
Everything's mushrooms.
Everything.
Hell, there are other sources considering pollen and pollination are causes of also thunderstorm asthma. Thunderstorms just pick up a lot of this stuff from the upper atmosphere and drag it down. Like we've talked about with the big guys. Almost all the
They
big
get
guys we were seeing are right before or right
after
after.
storms. Yep.
But like we've talked about, if the Aeroplankton is concentrated right before or right after a thunderstorm, you would expect to find the fish and the whales.
Right. They're going to come down and eat, right?
And they're probably using the same jet streams and the same, or they're reliable, the same weather patterns. There's also correlating evidence that links dust blow off the Sahara to predicted emergency room emissions in Trinidad. So it's picking it up, throwing it up our atmosphere, and kind of where it falls off the Sahara is in Trinidad.
It just happens to be the main landing spot.
Yeah.
Well, I guess if weather patterns are like, somewhat consistent, that makes sense because things are going to get caught up.
And yeah,
in
it's
that
going to keep
weather
happening.
pattern. Yeah.
And like they're saying, they're mapping this bio-arrow pattern is now, and it's a very limited understanding. You can kind of look up a map of it. It's very limited. It kind of just looks like a bunch of little swirls.
Yeah.
And they're like, okay, it kind of travels here and goes back around. But they think it's one global organism event, like a giant coral reef.
Okay.
Billions of individual little organisms that are making one
big
living system.
Gotcha.
Yeah. Any questions?
No.
There's also more spores, like we talked about with ferns. Ferns are plants that produce spores. They're vascular plants that deposit spores. And they're also pollen grains and fungal spores or components of aeroplankton. Fungal spores usually rank first among all bioaerosol contributing due to their counts of numbers, which can reach anywhere between 1,000 and 10,000 per cubic meter on average.
Okay.
So just saying, fungus is definitely the biggest part of the upper atmospheric biosphere.
Compared to any other
By
thing.
tens of thousands
Okay. Even clouds?
of living things,
Oh.
of material that's alive.
I was just joking. That was the one wrench I could have thrown in there.
Now, here's the one that some of our more keen listeners probably have picked up on already. I said arthropods earlier.
Yes, you did.
And, arthropods are insects, arachnids, crustaceans, that kind of deal.
Exoskeletons.
Exoskeletons. So have you remember Charlotte's Web? I think 2. No, it was 1. It was 1 when the babies all started leaving. Have you ever heard of raining spiders?
Oh, I've heard of that, yeah.
Okay, so a lot of these species of spiders, for example, it's called kiting or ballooning.
Right.
And they're not actually flying. A lot of them are using static electricity in the air to get pulled up.
Oh, yeah. Did we talk about this on the show?
A little bit before.
Okay.
Maybe a year and a half ago this time. It's been a while.
It's been a long time, but I remember having this.
So spider ballooning structures, it's a black thin point representing this. They kind of give a chart that I'm using. So small animals, mainly arthropods such as insects and spiders, are also carried upward into the atmosphere by air currents and may be found floating several thousand to 9 to 10,000 feet above surface. That's right hitting the layer.
Yes.
Going from the trope to the strat.
Yep.
Like it's that 10,000 foot mark is right where it's at. Aphids, for example, are frequently found at altitudes at about 10,000 feet. Just a whole bunch of aphids.
That's weird to find up there. Aren't those the little green bugs?
Yeah.
Okay.
That's the one version of an aphid. There's tons and tons of species of aphid. There's horned
gotcha.
aphids, and that's a huge group of insects.
They're the ones that eat all your plants.
Some of them do.
Oh, okay.
You're talking green garden aphids, yes.
Yes.
So ballooning, sometimes also called kiting, is a process in which spiders, for example, and other small invertebrates move through the air by releasing one or more glossomers of thread, catching the wind, causing them to become airborne at mercy at the air currents. The spider's usually limited to individuals of a spider or a spiderling after hatching. I was reading the line back.
Oh, gotcha.
A spider or a spider hatchling will climb to as high as it can. It'll stand and raise its legs in an airborne position upward. It's called tiptoeing. And then release a single thread of silk, from its spinnerets into the air. These automatically form a triangular shape parachute, which carries the spider away on an upward draft of wind. The slightest breeze will disperse the arachnid. The flexibility of their silk dangles can aid in aerodynamics of flight, causing the spiders to drift at unpredictable and sometimes really long distances. Even atmospheric sample collecting from balloons up to 6 miles in altitude and ships mid-ocean have reported spider landings.
That's pretty crazy.
So one of the balloons we were talking about from like the NASA studies and stuff, caught spiders. So we had one person say, I don't remember the name. One person's when we did this on Tony's show talking about them catching stuff, and they were complaining that they caught micro animals, nothing big. No, they caught spiders too.
Yeah,
which is big.
And they made
when you're talking about stuff that's bacteria and virus in size, a spider, a whole freaking spider, pretty big. Yeah. But in Texas, for example, I think when we were kids, is when the Texas raining event was really bad for spiders. Like whole towns were covered in silk. Tens of thousands, if not hundreds of thousands of spiders.
Didn't it look like Like the fields, the grass fields were like water because there was so much like web.
Yeah.
Okay.
So mortality in these events, though, are very high.
That's not good.
No, it's that kind of, it's like sea turtle. You make a lot of babies and just hopefully.
Oh, you mean by that way? Okay.
Yeah. Nematodes is my next large group up there.
I was gonna say it's big. It's big airplane corporations killing them all.
Nematodes. Nematodes, also known as roundworms, are the most common animal taxa on planet Earth. Period.
The only what I think of, I'm sure you know.
SpongeBob.
Oh,
He ate
every
the pineapple, and the pineapple shrank into a seed, which pineapples I don't think grow from seeds. I don't know.
I don't know either.
So yeah, these are the most common animal taxa on planet Earth, but they are also heavily found along aeroplankton. Nematodes are an extensive tropic link between unicellular organisms like bacteria and large organisms such as tardigrades, copepods, flatworms, and fishes.
Okay, fish.
Yeah, so these are the group that went from single-celled to multi-celled organisms. These are like the link when you think of quote-unquote evolution.
Okay.
So nematodes kind of have some stuff that is reminiscent of bacteria and some stuff of animals. They are technically an animal.
Okay. Well,
But-
yeah, I seen on SpongeBob. They had talked and everything.
But yeah, and so nematodes such as Amihydroius is a widespread, or using Amihydroius is a widespread strategy allowing them to survive unfavorable conditions for months, even tens of years. Accordingly, nematodes can be readily dispersed by wind. However, it is reported that nematodes account for only about 1 to 3% of wind drift animals.
That's not very many.
Uh,
Percentage-wise.
I mean, if you think about it, you're 3% of any animal, of the whole biome.
Yeah.
That's a lot.
Is it really?
Yeah.
I guess that'd be a pretty big biome, ain't it?
Yeah. I mean, we're talking about the largest biome on the planet.
Okay. Well, I guess 1% is a lot in terms of sheer numbers, but as a part of the overall biosphere, it's not that big
Right.
portion of it.
So yeah, along the habitat colonization by nematodes are those strongly exposed to wind erosion, shorelines permeable by water, soil, mosses, dead wood, tree bark. And we didn't know why for years, why we found all these nematodes in these heavy wind erosion areas. Now we know it's because they're being carried by the wind.
It's not their
It's where
fault.
the wind
They
is
don't want to be there.
slamming them in.
Yeah.
So the nematodes grow there. In addition, within the few days of forming temporary water, such as Pleurotomia, were shown to be colonized by numerous nematode species.
Oh.
So in these rain events where these nematode species aren't, it rains and a puddle forms, and now it's full of nematodes.
Nematodes, yeah.
And it's because the nematodes were in the sky with the rain.
They were probably the ones forming the rain.
Is it still exciting for you, or is it just me?
No, this is all like I'm learning something new every line you say. So
Unicellular microorganisms. A stream of unicellular airborne microorganisms circle the planet above the weather system, but below commercial airlines. Some microorganisms are swept up from terrestrial dust storms, but most originate from...
well, not. Oh, come on. I don't know.
marine microorganisms.
Oh, okay. So most of them come from the ocean.
The biggest block, one of the biggest unicellular organism block of the upper atmosphere is the same species we find in the ocean.
Unicellular, you're saying?
Yeah, it's unicellular organisms. It's the same species we find in the ocean.
Okay. So what, is it coming from the ocean?
Sea spray events is what we assume.
Or is it what's in the ocean coming from above?
Yes. Doesn't matter. At this point, with how old this planet is and how long these systems have been fighting with each other,
True.
you would never know.
Okay.
In my opinion, my humble opinion, you could, and you, especially unicellular organisms,
Yeah.
you could never prove which way it started.
Which came
I'm
first?
going to
chicken
bet
or
it's
egg?
the ocean, though.
Most life started in water.
Yeah. So I'm just going to bet it's the ocean. But these organisms from the marine environments, these micro unicellular organisms, are just being sprayed and are surviving in the upper atmosphere.
Which is crazy. The resiliency.
Thousands of feet. Or is it just because they're so similar?
Or that too. But that'd be scary.
In 2018, scientists reported that hundreds of millions of viruses and tens of millions of bacteria were deposited daily on every square meter of Earth on the planet.
all the time?
It's constantly, think about it, it's constantly raining viruses and bacteria from the lower to upper atmosphere on us. The presence of cyanobacteria in microalgae, which we're going to talk about raining blood here in a second, or the presence of airborne cyanobacteria, which is blue-green algae, which is not an algae, and microalgae as well as their negative impact on human health, have been documented many times researcher worldwide. So cyanobacteria is the one that kills Lake Erie every couple of years.
Okay.
The blue-green algae is what everybody calls it.
Yep.
It is not algae. It's a bacteria.
Okay.
I don't know where the name came from. It's just wrong.
But we know where the algae, or not the algae, the bacteria might have came from.
Yeah. No, yeah. But I'm just saying the name.
No, I know
blue-green
that.
algae, I don't know. But microalgae is also full. The upper atmosphere is full of microalgae.
Okay.
Remember that green slime we talked about a long time ago?
Yeah,
Probably
with
the
the
first
pilots,
episode?
the pilots flying through?
Yeah.
Yeah.
It's airborne microalgae swarms.
Makes sense.
Giant swarms of photosynthesizing. The photoplankton you were talking about. We're finally there.
Phytoplankton, yeah.
Phytophoto, it's the same thing.
Same thing, yeah.
Photoplankton, it's there. There are organisms in the upper atmosphere fully feeding off of sunlight, being the building blocks of these massive environments.
Wow.
Sometimes so heavy it appears to be green slime when you run into it. They're
just
not
like the
that
pilots.
thick up there. You run into them and you make them. You squish them.
Kind of like, a good example, Cruising USA, that video game. If you put in first person mode and you're riding, looking through the windshield, certain levels you could hit these flies. But sometimes you'd hit them so much it'd cover up your whole screen of flies. Same thing.
So cyanobacteria, though, for example, when they get upset, they get agitated as a swarm.
Okay.
And some algae do this too. They turn red.
Okay.
Red tide events.
Right, yeah.
It looks like blood. So these raining blood events we talked about, last season, where a cloud, these thunderstorms, which we already talked about today,
Right.
Thunderstorms drag this stuff down, which agitate it, so they turn red and they produce toxins.
They're all mad at the...
Well, they produce toxins too, as a defense mechanism.
Okay.
So not only is it raining what appears to be blood,
Yeah.
it's making people sick. When we talked about the raining blood events, it makes people sick every time it rains blood.
Okay.
It's probably massive swarms of atmospheric cyanobacteria and microalgae getting upset by being pulled down.
Say all agitated, worked
And why
up.
they couldn't find any evidence after, because you remember, they tested, when we talked about raining blood, they tested the blood and couldn't find it. It was mostly water.
Because it's not blood.
Because they're not looking for cyanobacteria and microalgae.
Yeah.
Because there's already cyanobacteria and microalgae on the terrestrial water.
Right, so why they be looking
So
for
it's
up
like
in
the
the
hidden
sky?
bullet kind of deal.
Yeah.
It's there. They've seen it.
Ah, I see.
But it's not the one that they think.
Or it's like the ice bullet.
Yeah. But it's there still.
Oh, gotcha. Well, yeah, like the ice bullet. The hole is still there. Like something, but there's no evidence of it.
So this is the second littlest researched area of these cyanobacteria and microalgae. Research is especially lacking on these presence of the taxonomy, composition of cyanobacteria and microalgae near these economically impacted bodies with so much tourism. We don't know what they're causing. We don't know if, why these rainy events. We don't know nothing of them. We just know they happen. So additionally, harmful microalgae and cyanobacteria blooms, like I just talked about, tend to occur in both marine and freshwater environments during the summer when these things are stressed. They're not animals, sorry. Previous work has shown that the Mediterranean Sea is dominated by several different species, but one of these species is also found in the upper atmosphere, but it may just be a close cousin.
Okay. Just a close cousin of the guy.
Yes.
Second or third?
So
Closer.
from doing this, as a consequence of the limited amount of research they've done on this study, bacteria are present in the air up to at least the lowest level of the stratosphere.
Okay.
So right there, what I just said is already different than everything we've already studied.
Okay.
They not only are people admitting that there's bacteria in the upper atmosphere of the troposphere,
They're emitting it up in the lower levels of the stratosphere.
they have just barely started doing the research in the lower levels of the stratosphere and near the ozone layer,
Okay.
and they're still finding bacterial life.
Like still teeming.
Yes.
Yeah.
There's no, in my opinion, I mean, they're worried because the ozone layer, the radiation above it, they say is much harder. And it gets colder, like we talked about, until you get high enough that it gets warm again. Because the atmosphere's weird.
Very.
Yeah.
So again, as this is already evident in this episode, there's a lot going on above us. Now we don't know. We just take for granted. You just look at pretty blue sky, stars at night. But between all that, there's a lot going on.
So a lot of these upper atmospheric species are actually ending up around urban areas and mountain ranges like we've already talked about. And that's due to these big wind front, these storm fronts hitting these ranges and either throwing everything up or pushing
dropping it
everything down.
Yep.
Depending on if it's a high pressure, low pressure, a lot of meteorological events. But I just wanted to put that out there. Clouds also. Clouds are kind of forming. there's some evidence to suggest, like we've already talked about, clouds are essentially living reefs of microorganisms. Like coral reefs are tiny, tiny organisms that build huge bodies. There's some evidence to suggest that these creatures may be pulling the water vapor towards them on purpose by some way, shape, or form, and kind of using it as a more habitable area. They need water and stuff like that. So kind of think of clouds as giant living colonies of tiny animals like a reef, or like a cyanophore.
Okay. Multiple things doing different
Holding their
tasks.
Yes.
Yeah.
But our giant organic UFOs also kind of look like cyanophores.
This is the rabbit hole just gets deeper and deeper. You're blowing my mind.
Now, before I get to the big guys or their impact on these little guys and their impact on the big guys, airborne microbiomes is the largest biome on the planet with the least research. We have understood more about the deep ocean trenches than this environment. This is a very new study and very exciting stuff we're constantly finding. Like I said, arthropods and worms and fungus by the hundreds of thousands are being found in the upper atmosphere right now.
Which is insane.
That's proven.
Right.
That's not even on to our organic UFO theory.
No.
Everything we've just talked about
It's documented,
is either
proven.
documented or scientists are talking about. Like the cloud thing, the cloud seeding, whether they are actually causing it on purpose or it's just a byproduct, we don't know. I could see some of these swarms causing it on purpose because it's favorable conditions.
Right. Like you said,
Ecosystem engineers, these animals, these fungus, these bacteria, they do that to make their environment better for them.
I like how you said too, pulls in the moisture, so it's got that. And then, that can trap more nutrients for them to eat.
And water's the hardest nutrient to get.
Yeah. And then when they have too much,
it falls.
It makes it rain. Yeah. Or if you really agitate them, lightning storm.
So already we've talked about how rare these guys are.
Yeah.
How little studies have been done. So there's not very good pictures of most of these species. It's mostly drawings. But yeah, so I have a couple artist renditions, and I'm just going to hand you the iPad for a second.
Okay.
Because I think this is about to blow your mind.
All right, let's see this.
So these are all kinds of aeroplankton.
Whoa.
Now, but look at them. Kind of describe what you're seeing.
It looks like a. Have you ever been in like science class and you look under the microscope at like a little pond water
and stuff like that?
Pond water, yeah.
How many of those look like our organic UFOs, though?
Oh well, 1, 2, 3, 4. Oh my gosh, big time that one. Okay, there's more.
Don't go too far down. Don't go. Don't ruin my ending.
No.
Just those two pictures.
Okay. Yeah, the ones in color are just getting a little better look at. Oh, and then there's some. Look at that. There's ones like they're zooming in on. I think they are so small that they.
But how crazy! They look like our living disc. They look like our jellyfish. They look like all these UFOs, our balloons, our manta rays. There's literally one in there that kind of looks like a big manta ray.
Yeah.
How crazy is that?
No, this is weird. Some of these do, and they look like other like biological things. Like this one looks like a lady's uterus, or wouldn't you say?
There's a lot of animals that look like that.
Okay. Well, then it's mimicking other. It's just mimicking all sorts
favorable
of different
shapes.
Yeah, favorable shapes in other life.
In nature. So
there you go.
One of the things. So I have two thoughts with our
you biologist and nailing all the terms just right.
So I have
favorable shapes in nature.
Two thoughts with our giants. So before I continue, to understand, in a lot of marine biology books, there's a saying roughly goes, to understand whales, you must first understand plankton.
Mm-hmm.
So for us, and I really think it is important, to understand what we believe are living up there, these massive organisms.
You got to understand these
their
little
food
guys.
source.
Yeah.
Because these are the building block of their environment. They're hyper-defined building blocks, too. They may be one of the oldest environments on the planet. So that string thing you've seen, those are mycelial networks.
Yeah, okay.
That's like the mycelia, the roots.
Holding it all together, yeah.
Like coming out of one of the spores and going, like making like a net or a kite or,
Yeah, something to catch air and move around easier.
So I have two thoughts, and then I got another surprise article for you.
Oh, I love surprises.
Two thoughts. First one is some of our giant organisms are, quote unquote, actually cyanophores. A bunch of these little tiny guys holding together. So when we did our live show, one of our first live shows, we showed that video of that sparkling cloud that looked like it was full of little fish.
Yep.
I believe personally
Now or back then even?
then I talked about it a little bit. Now doing this research, I 100% am sure in my personal beliefs that's what we were seeing. So for everybody that didn't go to the live show, it's like a cloud glides in, and you can see these glimmers in it, and the cloud has like a gaseous edge to it, but you can tell there's something more solid in the middle,
rather than just your plain old cloud that's fluffy.
It is gliding.
Yeah, it's moving.
I think
not
that
like
was
a normal
a colony of microorganisms from the upper atmosphere that it's either holding on to water vapors or producing them as a defense mechanism or a cloaking mechanism for predators.
Okay.
So it's a cyanophore. These giant, and we talk about ocean cyanophores, are gigantic organisms they appear to be.
Yeah.
Except they're actually billions or millions, if not billions, of tiny little organisms working in tandem together to form one big body. So I think that's what some of these events are happening.
I wonder too, like it just, them collecting together to make that body, and that's the same thing how if they are like the clouds or what forms the clouds, just the way the sun reflects off them, it's automatically that white, looking cloud color.
Yeah, mycelia networks, when you actually can see them, they look like that.
Yeah.
So what if it's a body of mycelia, these actual big fungal colony, is kind of holding on to itself and it just appears to be cloud-like.
Right, exactly. Not necessarily that's trying to like camouflage or blend in, but it's just kind of the byproduct of being up there. It's just, I wonder too if, let's say we could somehow recognize what's a normal just cloud and what's maybe one of these guys, if you could like differentiate right then and there, like the difference between, because there's been times, I'm sure you've looked up at the sky and noticed like, oh, well, there's, it was clouds full of skies, but one of them's like floating under or just looks different. Yeah.
So did you see the confessionals just posted today a video of 3 giant circular clouds kind of going against the grain in the middle of the cloud bank?
Oh.
But you can see them just diffusing the clouds around them.
Oh.
So it could have been 3 gigantic colonies.
Yeah. Wait till these things like team up and they
I have
realize.
another one for you.
Oh, no.
So what do you think about that? That some of these are actual colonies of these little tiny guys that we can document.
Yeah.
But some of them are forming massive bodies, and that's what we're seeing.
Like man of war jellyfish.
Yeah.
Yeah. Oh, no. If it, so far it has imitated the ocean so much.
Oh, it is the same thing. All these species are the same too.
Yeah.
Isn't that crazy?
So why wouldn't they automatically? Yeah, it is crazy. Why
They're
wouldn't
the
they?
same species. They're not even imitating anymore. They're literally spraying up from the ocean and just living in the upper atmosphere.
Just doing it up there instead.
Like, this is nice.
And they figured it out because some of those shapes you can tell they're meant to
Be in the aquatic.
be in the wind or just be in the wind.
Oh, yeah.
Like,
No, there's definitely a lot of aerodynamic ones. Now, here's my last, well, not my last thing, but one of my another big twist for you.
Oh,
I'm
another
so excited.
twist. M. Night Shyamalan.
So think of the open ocean sunfish.
Okay, the big guy.
The biggest
big
bony fish on the planet.
As heard on, if you wish to learn more about that.
It never aired.
Why not?
Because remember, it had an audio glitch in it, and we have to re-record it.
Oh, that's right. I forgot.
We will do an open.
Yes.
We had a mess. Anyways,
Sorry.
it's coming.
I forgot that happened.
I was just trying to let you forget some facts about the ocean sunfish before we redid it.
Okay.
So it's a bit.
Yeah, it's still the amazement and wonder of the first time. I love that fish, though.
Anyways, do you know that their fry, and you do know because we went over the facts, their babies are considered platonic life?
Right, because they're so small, right?
Yes.
Yeah.
They're not the only ocean giant to have they're the biggest ocean giant to have super tiny babies. But lion's mane jellyfish that can be over 115 feet long.
And their babies are.
And they're platonic life.
See, okay,
So
I see.
You see how similar some of these look to our organic UFOs? What if they are literally the babies of our organic UFOs and they will grow to be giant, or they have the chance?
So what you're saying is we need to, throw our balloon up in the sky and collect some of these little babies, bring them back down, then raise them to do tricks and just raise them, get them bigger, and see what it turns into. A giant boomerang-shaped glider that's
You can saddle up.
gonna eat a cow. I don't know.
So I think they may have already, and like I said, they're still processing these species.
Right? Yeah.
I mean, we talked about over hundreds of thousands of species, depending, spore, bacteria, animal, all
it's kind of a lot.
unicellular stuff.
That's a lot.
So they're going to be categorizing this stuff for the next, 3 or 4 decades. The stuff they've already caught. Think a group of scientists, the fungal spores they've already caught,
Right.
It may take a small group of scientists 3 or 4 decades to categorize them all
Just to sort through it.
and see what's new and what's not.
And then not even discovering or learning about them.
Yeah, not researching them at all. Just putting in the known pile, unknown pile.
Man.
Known pile, unknown pile.
That's crazy.
This is what the open ocean environment was 100 years ago. When every time you went out, I'm not talking deep ocean,
Yeah.
which we're still doing.
We're still doing it, of course.
Open ocean, like every time you took a scoop of water, you discovered new species of planktonic life, micro life.
We should do that and then name one of them after our podcast, and it'll go forever down in the history books of like the cryptids of the corn.
No, it'd be Corneus Cryptidae.
Oh, I like it.
But I think some of these guys that they have even caught, that they've started to draw, and some artists have started to get a hold of some of the pictures. May be the babies of the titans we've been talking about.
Wouldn't that be nuts?
I think it is true.
I believe you. Like we said with the sunfish. With what was the other thing you said?
The sunfish is the big one, but that's a bony animal too.
That's what I'm saying.
The lion's mane jellyfish.
That's jellyfish.
And there's some jellyfish that are absolutely monstrous inside.
And what's up in the atmosphere?
Cephalopods are another one. Giants and colossal squids. Their babies are not true platonic life, but they're so tiny. They're close.
Close. But what have we discovered up there?
The ocean life lives up there.
Jellyfish live in our atmosphere.
Cousins of jellyfish. Now we can't say no true jellyfish to our knowledge has ever been found in the atmosphere.
Okay, but
there are close
what
cousins
is it? Under the same family.
Yeah, I think it was
genus.
I think it was order.
Oh, the same order.
No, it was family. It was same family.
Okay.
Anyways, yeah.
Either way, they're up there.
All right. So have I blown your mind thoroughly?
It's been, it's getting.
Has it been entertaining? I know it's been super science heavy.
It's really no, but I feel like I've learned a lot. Like I always knew ever since we started talking about organic UFOs that there's life up there. We knew about the nutrients. We learned that before, but this has taken that step to a whole new level that opens a lot more doors.
Okay.
For possibilities. Okay. Well, what?
I have a small 3-minute article I want to read to end the episode on.
Okay.
So I came across this crazy article and the similarities. So it's called Co-Migration. Aeroplankton is the name of the article by Brandon Yondell. This was written in 2016.
That's not okay. It's not that long ago.
A pretty good time ago.
8 years ago. Before the NASA study.
Yeah, actually, it was before any of this study.
Yeah.
So this right at about 3 years before this was the pinnacle of just understanding what aeroplankton even existed.
Okay.
Before just thinking it was a small handful of species.
You would think at some point somebody would have just threw a net up in the air, then looked at it under a microscope and seen like, oh my goodness, look at all this.
So I found this article on some absurd website.
Angel Fire.
No, it was a good website. It just was like...
I'm just kidding.
The website had nothing to do with anything like this.
Okay.
It just seemed like one of their authors, like me, got passionate about the aeroplankton subject and just wanted to write a small article about it.
Gotcha.
So I just thought, I'm just read his article and kind of see. It's really weird.
I'm ready to hear it.
Many occupied regions of the world are turning arid due to rapid change in the global climate. This is causing this displacement of entire ecosystems, including non-human and human inhabitants of regions. In the Middle East especially, extended droughts are leaving communities and neighborhood cities without food and means of survival. This desertification, along with the climate of war and political turmoil, is leading to the mass outpouring of refugees. Global politics, and it takes a turn in a second. I don't know why he starts tying into stuff.
I get it. I understand why he's bringing it up, but anyways.
Global politics trends and politics are shutting off many safe regions for refugees, forcing them into periods of extended migration. The Bible suggests that similar refugees out of Egypt wandered through the Middle East desert for 40 years, surviving on nothing but mysterious manna from heaven that appeared, which may have been raining meat.
I more think of like the sky jelly phenomena.
Yeah, that's what I'm saying. Raining meat phenomena, these star jelly, all this. Maybe God sent down a manna rain, but like, eat this. It's good for you. So the author continues, aeroplankton may have been such a substance with potential to harvest, process into food, water, and cultivate into nomadic ecosystems housing humans and non-human migrants.
Okay.
So this author is like, they may be able to harvest, process into food and water, and cultivate whole ecosystems from aeroplankton. And I'm going to skip his little thing of aeroplankton because he just describes it, and we've been doing that for the last hour and a half. It is noted that aeroplankton, unlike marine plankton, have not okay, here's where our first argument with the author will come. It is noted that aeroplankton, unlike marine plankton, have not been exploited by evolution yet, and therefore the sky remains one of only niches that is inhabited on the planet by no large organisms.
See, it's just not documented yet.
Yes, and he may not have any idea of anything we've just, we talk about.
Right.
But from the outside looking in, there's tons of plankton up there, and it's weird. There's no whales.
Yeah, and you think that would be like.
The plankton in the ocean sustains billions of species, including massive whales, many of which flourish solely on the soup of plankton. However, very little life has evolved to feed on aeroplankton as far as we know. Flying species such as birds and bats might periodically feed on some of our larger specimens, but are inconsistent. Most of the airborne soup remains untasted and unknown. And there is no aerial equivalent of a whale soaring through the sky with an open maw gulping down the plankton in the sky.
That
foolish man.
I was gonna say, this in 2016. The Ohio River manta ray's been around
206.
Yeah, still 10 years before.
Well, I mean, really, nobody talked about the Ohio manta. Like, very few people have ever talked about it. Creepy Acres did something on it years ago.
But I mean, it takes one quick Google search to search for atmospheric life.
But nobody called that. Remember when we read it? Nobody said it was an atmospheric animal.
Yeah, I guess.
It said Ohio River manta ray.
Yeah.
Even when you see the Cryptid Wiki thing, everybody thought it was in the Ohio River.
I guess, yeah. I don't know.
You got to keep. We're coming from a mind looking into this.
True.
Stuff.
Yeah.
From the outside looking in, it's impossible to find.
Yeah, I get it. Yeah.
Humans could be among the first species on Earth to occupy the realm and open up the use of aeroplankton in a broader evolutionary world. Basically, I'm gonna just tell you kind of something about his article.
Okay.
It's very neat.
What's he suggesting?
Giant kites and systems of breeding and harvesting aeroplankton.
Okay.
Now, I want you to look at some of his designs, and we'll describe them. These giant these giant filtering systems. What does that look like that he drew?
A hot air balloon?
But look at the tendrils, the nets.
Oh, it looks like jellyfish.
Giant atmospheric jellyfish. He suggests humans could make these to harvest aeroplankton for food, fuel, and other resources.
What if we're already doing this? Oh, no. I just got the look, guys. I got the look. I ruined something.
After reading this article, my thought is we talk about some of these quote-unquote organic UFOs that don't quite fit in with what we consider real organic UFOs. They may, in fact, be man-made design systems for filtering aeroplankton for food and fuel resources.
For corporations and rich elite that can afford to put these things up there.
You remember the one jellyfish we talked about that was like tapping into power lines? Out west. It wasn't like, it was halfway between biological and halfway between.
What do you mean tapping in the
mechanical.
telephone?
It was hitting power lines and looked like it was draining power.
Vaguely,
We may have done that in the live show, actually.
Yeah, vaguely it does sound familiar, but I don't remember the details.
So some of the one-off, really weird organic UFOs may in fact be harvesting mechanisms built by either the elites, the government, I don't know.
Government, yeah.
But to harvest.
Air or Space Force.
So yes, you did steal my thunder on this one a little bit.
I'm sorry. I mean, but we know those balloons. We know we have big balloons up there. We know we have a lot of atmospheric balloons up there.
But these are farming structures for certain species.
Yeah.
Some of these may be new medicines, fuel sources, all kinds of stuff.
Wow. This is what's going to charge your Tesla cars.
So
Since right
it is
now it's
important
diesel.
The importance to understand whales is to fully know plankton. These tiny things are the building blocks of the biggest ecosystems on the planet. Some of these animals may in fact be the larval forms of titans from the sky, like the ocean sunfish.
Right, exactly. Life finds a way.
It just keeps mimicking. It keeps being the same thing as the ocean, just tenfold.
And if there's a niche,
where are the whales?
Where are the sky whales? Isn't that a song or something?
You know what we forgot to do at all is play the sponsor thing or put an ad in. I've been too excited. We'll do it here at the end.
Okay.
I can't do the ad thing, but
we can do the sponsor
I can do the sponsor thing. So what are your overall thoughts? And I'll go into my final thoughts after you.
I mean, this is all very mind blowing. I'm glad you showed me that. I think you should post those.
If you remind me, I will.
I'll do my best. You're asking the blind leading the
Hey,
blind.
okay. Somebody at home, shoot me a message on Facebook or Instagram or an email when it's
Where's
this episode comes out. Hey, post all the pictures.
Yeah, there you go. But that part's pretty mind blowing. Honestly, all this is very eye opening. Or what I say earlier on a different, I think Patreon episode, mind's eye opening. This really honestly gets you thinking a lot more because, I wasn't aware of the vast amount of life we knew there was a lot of life up there, but not to this fold or to this amount. It's insane. And yes, if it does reflect the ocean, just like it has in every other aspect we've proven now, or that's been proved, who's to say that the other stuff that just isn't been put on paper yet isn't already happening when the rest of it already is? One thing leads to another on this one.
So this field of science, this field of study is very new in its new form.
Mm-hmm.
Like I said, they've pulled hundreds of thousands of species out of the air. We're not talking anymore of the NASA study, the 14,000 species.
Yeah.
We're talking that they've been doing this for a while. Hundreds of thousands of species, mix of fungus, virus, bacteria, animal, unicellular life, all everything. Arthropods. They're getting spiders up there.
Yeah.
Where are the whales? Every time I look more into this subject, I'm more concrete in my beliefs that there are large upper atmospheric organisms that are being mistaken for true UFOs. And I know they are unidentified, so they are a UFO essentially. But what I mean is, they're being mistaken for craft. They're being mistaken for aliens or whatever. And you just look up and there's a giant manta ray shaped thing. And it's huge. And these are our whales. These are our giant, and we've talked about the sharks and stuff too. We've painted a good idea. And I think there are, I think maybe later in season 5, this season, we'll dive into the skyfish.
Okay.
There's a whole phenomena we've never touched on this subject at all yet.
Okay.
Which is small schools of stuff the size of your hand that literally look like giant schools of fish. And people see them, they do like tornado, like they're avoiding predators or something like that.
Gotcha. Yeah. Almost like like how big schools of fish when they pile up and a predator's coming through and they make some crazy shapes or
that kind of stuff. So I think even the connection that this episode has with the ocean, that some of the species are from the ocean. So it's just the same environment. It's just so similar. And we keep painting the same picture. We keep beating the same horse. But there's more and more evidence.
Mind blowing. This one's been a lot more.
And I really think in the next decade, we'll have one of these guys land on a slab. I think the jellies and the mantas are kind of hard because I do think they're mostly gelatinous.
They'll fall apart before
they fall apart and they break apart.
Yeah.
I do think some of the smaller ones are more hard-bodied.
Kind of like a barrel-eyed fish's head,
Yeah, there we go. That's this week too. Okay. I'm trying to think of how all this Joe's schedules work. But yeah, so I think this just proves gives more credence to the idea of supersized entities in the upper atmosphere.
I think we have to put a call to arms, to our listeners. Write your local congressman, send them a letter and ask them, where are the whales?
Where are the whales? Nothing else. Don't explain yourself.
No, you can write Aeroplankton. Just name all the stuff that
you get 15 words.
Yeah. To name all I'm asking you to, all the little, Aeroplankton, you got.
Fungus.
Yes. Yeah. You got this.
Arthropods.
That.
Where's the whales?
And then at the end, where are the whales?
And I just think we're at the bottom of their environment. So think of us as in the deep ocean whale fall events are the ones that have died, the ones that are sick and we see.
Yeah.
Whale fall events are super rare.
Yeah.
For a whale to die at the surface of the ocean
and make it all the
way down
before something else.
Before it's into such small pieces, it doesn't matter.
You can't see
and I think that's what's happening with these guys, these giants. The true. But I do think some of them are like reefs. Some of them are these living clouds we've talked about.
Yeah.
They make like the carnivorous clouds we've done and stuff like that. Maybe tiny groups of these guys that are hyper carnivores. there may be a whole colony of them living over the Bermuda.
Like the what's that one cloud that feels like a cat's tongue?
Yeah, so there's that's the dog's tongue.
Dog's tongue.
That's the
I thought it was cat.
no, because that's the clouds in Ireland, and then the pink carnivorous cloud in Florida.
That one. Okay, the Florida one. That's
Is
the
a
pink
carnivorous
one.
cloud.
Yeah,
that like bones fall out of.
but you're right. Yeah, and what if they're it's pink because it's agitated, like you said.
Mm-hmm. And then the ones over Bermuda are green.
Yeah.
And how many weird paranormal phenomena in the Bermuda Triangle? Another different season finale were green. Like it's like all these weird phenomena that'd be like this happened, my plane acted weird, and then there was a green fog, and then green fog, and then green. And it's just
maybe it's an area where all these nutrients and stuff are
sure
small things, whatever you call it, microorganisms are getting pushed to and gathering in this area, and then they're all banding up and like attacking everything that flies in, planes and anything. That's why they all go missing. Then occasionally they don't get enough planes. Let's go down and get a ship. We're hungry.
and just eat all the people, and that's where the ghost ships come from.
Yeah.
As in, ghost ship is an abandoned ship, not a
Right.
a ghostly ship.
Right. Like the Flying Dutchman.
Yeah, different things.
Another SpongeBob reference. What is going on?
Everybody at home, you've enjoyed this heavily science episode.
Yeah.
And I know it's very little. What kind of? It's very little of the cryptozoological, but in a way, it's not. It's all cryptozoological.
Yeah,
because it's
100%.
brand new species being discovered, and all this kind of thought is ignorant to me that there's no big things.
Right. Yeah. Where are they? Where are the whales?
Because we're not looking yet.
Right.
The systems, like we talked about, the systems we're studying these things with are tubes that are sucking in air.
Right, yeah.
Tiny little things.
How do you?
And this, 100-foot wide manta rays is kind of flying by and being like,
Do you know who we need to team up with to catch one?
Steve Irwin.
No, come on, think about it. Who do we need to? You need to combine forces with him, and a union you would never see coming, a union that should never be in your mind. But now it's time. You must join powers.
I don't want to name the person I think you want me to name.
I'm not really naming a person. I'm naming a group, a whole culture of people.
Is there Smithsonian?
No, come on. Who's the best whale hunters? You know.
Oh, the Japanese.
You and the Japanese are gonna.
No, thank you.
Are gonna team up.
I don't want to kill one.
No, but you need one on a slab for science. You need one.
It would be eaten before it hit the ground.
You know what? You're
They'd be chopping it up.
making sushi out of it.
They literally cut.
But-
I don't want to start this fight with you.
No, I'm not.
They literally cut up whales where they're still alive. You think this manta ray is going to make it back to the ground?
Think about it. Where are the whales? I know who can find them.
A sushi restaurant.
I know who can hunt them. It's the most unholy union you'd ever see.
It
Imagine.
wouldn't happen.
This is like a cartoon. This is like a TV show writing
It'd be
itself.
up there. It'd be like South Park with all the harpoons and the swords, and they're just up there on the top of a plane.
Oh yeah. So that's the actual scenario. You're actually up there like studying, looking for them. You're like group of scientists, and then you see like floating by on another like hot air balloon. It's a group of the Japanese are like hunting the whales now, and you're like
The Japanese government. We want to make that very clear. I don't care for the Japanese whaling government.
right. That's exactly the only person we're targeting. Or
Japanese people I have absolutely no issue with.
Right, yeah, no,
it's
it's
the
the-
Japanese
it's the
whaling.
whalers.
It's the whalers,
Right.
Because the way the Japanese whale is one of the worst atrocities to nature. What we still do.
So either you're going to team up with them or you're going to find them up there and have to battle them again.
I'll just start giving the manta rays guns. If you could give a whale a gun, tables would turn very fast.
I think the whole world would change real fast.
Whales on Still is a book about that. Well, that's not the first time we brought up that book.
That's true. Yeah, that's funny.
Before we close out, I do want to play our little sponsorship ad.
Yes.
They will start. We're trying to make the sponsorship ads fun, so they'll start coming on the beginning of episodes. Like this one was supposed to be at the beginning of an episode. I may still cut it in if I feel like editing.
We'll just leave it here. If you stuck around this long, get ready for this wonderful new ad from our newest sponsor.
Which one do you want me to play?
Let's do the Bigfoot one first.
All right, guys. So this is going to be thank you to our sponsors, Flavor of the Forest. Get their stuff in the links below. We get a kickback. They're awesome. They're listeners.
Oh, wait, and before we play it, let me just read this little thing they said. What flavors of? Well, no, just play it.
Why are you going to read that right before an ad?
Right, you're right. Okay, just go ahead. Flavors of the Forest. And I'm here interviewing the great Bigfoot. And today, Bigfoot has prepared me a meal. Bigfoot, what did you make for us today? Ooh, fried porcupine on a stick, eh? Oh, grilled. Sorry, excuse me. Yeah, it's that. Ooh, this tastes absolutely delicious, Bigfoot. How did you create such a amazing dish? Oh, it's all in the seasoning, you say. Huh? Oh, so what's your secret ingredient? Oh, this right here. Flavors of the forest, Bigfoot breath. Raw garlic dust. Oh, this is raw, straight, freeze-dried garlic? No filler? Wow, this tastes amazing. Oh, you've got... Oh, wait, I'll try that too. What's that you got? Oh, okay. Well, I guess I'd never had deer heart, but let's give it a go. Oh, it's a little spicier. What's in this? Spicy raw garlic dust? Wow, also from Flavors of the Forest. Well, where can I find this? Oh, in the links below. So if you're looking to season up your meal today, why don't you go to the links below. Reach out to Flavors of the Forest at flavorsforest.com and get you a bottle of raw garlic dust or spicy raw garlic dust, also known as Bigfoot breath. Talk to you later. And there's our newest ad from our...
I can't wait for the other one.
Oh my gosh, the other one's... So just so you guys know, peel back the onion a little bit, or peel back the garlic here on this one a little bit. Yeah, we just on the spot, like, okay, let's do
some fun ones.
So it's hard to talk like out of your butt when you're...
I did fine.
Well, I know you did because you were leading it. I struggled. We'll get it better. I'll get better.
We'll script them out.
But yeah.
So hopefully you guys have enjoyed this episode.
Yeah.
Hopefully this gives you some more insights of this environment idea we're building for the upper atmospheric organisms. I have been the great and powerful Mr. E.
I've been JClone27.
We'll catch you next week with more Cryptids of the Corn.
Bye.
Hey guys, thank you for listening to Cryptids of the Corn podcast. Remember, the best way to support the show is share it with a friend. But if you are craving more of the J clones
And more from Mr. E.
there's always extra content on Patreon.
And our paid member space on cryptidsofthecorn.com.
We'll catch you next time with more exciting, fun, and informative information. Bye.